Hello everyone, welcome to ECE 209 Laboratory for Winter 2021. We are now going to unbox this laboratory kit that just arrived a few days ago, and I've kept it aside for at least 4 days so that we don't spread any coronavirus. Okay, so here are the arrows that we should be looking at before opening, and we can open it from this side. Let's just cut the tape, not the cake, of course. Um, cut the tape from both sides. It looks like it's ready to open. Yes. Okay, so here's the box that we've received. It includes part list and the experimentation box, lab kit. Put aside the cutter so that we don't hurt. Okay, so there are some instructions on this paper that says this lab kit is being supplied to you for the purpose of completing the experiments required for ECE 209. The lab kit is to be returned at the end of the term by April 23rd. Since university staff have been directed to work from home until past the kit due date, we will not be accepting in-person returns. We have included a return shipping label for you to use. If the kit is lost, damaged, or not returned by the end of the term, you will be charged up to the kit's full value of $400. If you have any questions, please contact your lab instructor, which is me in the case. And we have provided the list of all the lab instructors for your specific section, or the lab kit team at eceinfo@ualberta.ca. Upon receipt, so they have informed us that upon receipt, please review kit contents to ensure you have all parts listed. Number one is digital multimeter. So let's see if we've received a digital multimeter inside. Okay, let's open the box. And here I see a small box which has a label digital multimeter. Let's open it and see if we've received all the items. Okay, so it says that digital multimeter with set of test leads, which are these two, red and black, and set of alligator clips, which are these. You see that their shape is like an alligator, red and black again. 9 volts battery and user manual. So 9 volts battery should be already installed inside. And this is a small support opening at the back, so we could make it stand at any surface. Okay, so we've received all the components. Let's see if it's working or not. Currently it's in the off state. I've just turned it to V voltage state, and it shows me the digits, so it's working fine, and uh, the battery is already installed inside. Let's put it aside and see what we've got next. The next is analog discovery 2. So let's see where it is. Should be inside this small box, another container. Yes, so analog discovery 2 is inside this box. It has also got a micro USB programming cable, so we can see the plug type. This will be used. This will be connected to the Discovery 2, to the analog Discovery 2 port here, like this, and the second port will definitely go to our computer. What else we have? We do have 5-pack. We have got some connectors which will be connected at the back there. So we see that this is how we will connect these cables. And we've also got another type of header which we may use in case we want to plug it directly into the breadboard. So we will see how that can be done. So we simply insert this here inside, and we've got a breadboard, so we can simply place it like this. So it just gets inside the board and we can get all the cables. We will discuss about the breadboard later. You can just easily unplug it. Just try to be gentle with all these equipment. Next we have this breakout board with ribbon cable for analog discovery that we've just saw. I'm trying to unplug it and not break it, so just do it gently. From both sides until you can easily take it out. And so the next thing is a breadboard, which is here, and we use breadboard to connect different components. And just a quick look that these two at the top, horizontal lines, are already connected from inside. So if I plug in something at the top, that point is internally connected to all these points ahead. Same goes for the second row. These are all internally connected. And then we have these ones in the middle, which are labeled as A, B, C, D, E, F, G, H, I, J. These are vertically connected from inside. So these 1, 2, 3, 4, 5, F, G, H, I, J are internally connected column wise. So I have like several connections here in this column, and then again same goes for the bottom row. So these 5 are internally connected. We will see in when we perform the lab how this works. The next is a wrist strap. Let's see, where is the wrist strap? So this one. This is very important because when we are working at homes, or even if there is any carpet or thing around us, like which can potentially create charge in our body, and then if we touch any electronic component, and if that charge is released, it will potentially damage the equipment. So whenever we are using the equipment, just try to wear this wrist strap before we touch any equipment, make sure this metallic part is touching your wrist, and then connect it to ground that you might have available around. So it is usually the third port available, or you can connect it to any metallic shield around you. Like I have this one, so I will connect it there. Okay, let's check what's the next thing in the list. So besides that, we have jumper wire kit. So this is jumper wire kit. So whenever we connect anything on the breadboard, we need jumper wires to make different connections. Try to be gentle. If you pull them out hard, they might just break, and later on when you perform the experiments, you won't know why it's not working. So let's try to get one out of the box, of the bag. So there. So usually we use these jumper wires to connect different points on the breadboard. They will slide easily inside the board. Suppose from here we need to connect these two columns. Now these two columns are internally connected. If you have connected something here, you can simply access it from this point as well, because as we discussed before, these are internally connected. Okay, and sometimes you might have a problem with these cables that they don't work. The best way is that we can use a digital multimeter to see if they're working properly or not. Let's do that small experiment that is known as connectivity test. So it's on the second number on my multimeter. You see that there is a symbol of bell, like an alarm, and you will hear a beep if the continuity test passes. Let's try it. So you just connect this black one into the COM port and the red one into voltage ohm port, and simply touch one end of the wire. Let's unplug these. Now to test, you can use the crocodile clips. Just insert them into your digital multimeter. Now they're connected. Now we can connect one end of our wire to this plug and second one to the adapter, and so we don't hear a beep. Shows that the okay, so currently it's showing the resistance and it's a very small resistance. Let's change the function. Now it's on the diode function. Now you see we hear a beep. So this dial allows you to select different options, and in every option there are different functions, so you have to select function by pressing this button. So first it was on ohms, now it's on the diode function, the third is beep function. Now this tells that the wire is okay. Let's turn it off. Okay, I'll put back the wire. Back inside the bag. Okay. Next, there are a few additional things in the ECE 209. That is IC current source 1% mounted on protoboard. So this is CK209. Okay, yeah. So this is CK209. I see that it's written ECE 209 on the list, but it's actually CK209 parts bag number 1. So first of all, it says that there is an IC current source, which is just here. You see there's a small IC on the board, the PC board, and you can gently pull it out. You will see 3 headers at the back. You can simply slide them in. If you want to put it back, sometimes they don't go inside easily, but don't press it hard, else you will hurt your fingers. This way. Make sure you don't press it on your fingers, else it will just hurt you badly. The next is there are a bunch of red LEDs. You can see that these are red colored LEDs. And then there is a connection header 6-pin. Now let's get to the second bag number 2, which is here. Pull the things inside out. So we can see that there are a bunch of resistors and a potentiometer. So this one here is a 1 kilo ohm potentiometer, and half watt is its power rating. And you can easily mount it on a board. Let me show you how you can do that. If you pick the breadboard, you can simply insert it like this. So you can then just change its resistance by rotating the knob. It's a very useful component. And then we've got some resistors, and you will learn how to read their resistance values. You will see there are color codings on the top, and in the first lab you'll see how to read these color codings. And we can also use the multimeter to determine the resistance, the same way we were trying to test the jumper wire. And remember, it was on the ohms function, so if we connect this resistor, the multimeter will just simply read out the value. Okay, got quite a few values here. These are different values: 10 ohms, 240 ohms, 20, 2400, 220, 470, 680, and the list tells you all the values. Okay, now let's move towards the third bag, which is here. So the third bag should have film capacitors and an inductor, 10 milliohms inductor. So let's get the stuff. So these two big ones, you see black colored, 103, which tells us that this is 10 millihenry. 10, then 3 is read as milli. It's actually -3. So that's 10 millihenry. Then we've got a couple of capacitors. Yeah, so this one here is 1 micro. You can see it's written on the capacitor that it's 1 micro. We've got two values for 1 micro. And then there is one 0.22. So you see that it's micro 22 written on the capacitor. And here are the two values, and then we've got 0.1 microfarads. So these are the three capacitors, and this is the 10 millihenry inductor. So I believe these are all the components. Let's put this one back. So guys, we just saw all the components that I've just received in my laboratory box. The kit includes several components that we saw. There was a multimeter, there's a discovery board that will be used as a power supply, frequency generator, oscilloscope, and we'll be able to get a lot of functions through that discovery board. And yeah, we also had a wristband so that we protect the components that we use and we don't discharge any electrostatic. So this is actually an anti-static wrist strap. Let's put all the components back. Alright, so all the components are now inside the box. Okay guys, I hope this video helped you understand all the components that you've received, and we will be using a lot of these components to perform our labs, and I will demonstrate you how to perform the labs. So you could perform them remotely. Thank you. In this video, I'm going to demonstrate lab number 1. So let me show you the screen. So my name's Nabil Khalid, and I would like to discuss about how you will access the lab content. So all the lab content is available on eClass. You can go there and you can find the schedule for the whole semester, and let's go over it once. So lab number 1 for section H21 starts on 2nd Feb, and we hope that you will get your equipment by then. And then for section H41, it's going to be on 4th Feb. And then for for H45, it's again on Feb, but it's in the afternoon. And for this week, I will be your lab instructor for section H21 and H41. And for the afternoon session, Chai will be your lab instructor, and I will be helping you guys. And for the next week, we will have different TAs and allies. So for H22, Ehsan will going to be the lead instructor, and Brendan will be assisting. And on 11th Feb, we will have the lab one for H42, and Jajan will be your lab instructor, and this is how the schedule will be. So in these 2 weeks, we will be doing the lab one for all the sections, and then there will be a break of almost a month. There will be a reading week, and after that the labs will start again. So second lab will be on 2nd March, and then the third lab will start on 16th March, and then again there is a gap for lab 4, and after the gap it will start on 6th April. So since lab 4 is going to be ended by 16th April, so we are not going to ask for post-lab questions in this lab, and you will just perform the experiments and record your results, and it will be evaluated based on your lab work only. Okay, so this is how the schedule is. So lab reports are due 7 days following each lab by 4:30. So for example, lab number 1 for H21 was conducted on 2nd Feb, then their lab reports will be due by next week, Tuesday, at 4:30. And for H41, it will be next week by Thursday at 4:30, and same goes for all the other sections, that they will have 1 week to finish their post-lab work and submit their lab reports. And lab 4 will not have any post-lab work. So lab manuals will be available 1 week before the first lab starts, and this demonstration video is going to help you how to perform the experiments. So for your respective sections, please make sure that you contact your TAs for any questions, and the contact details are given in the schedule for all the TAs. Lab reports will be submitted on the e-class. You will find the links for your specific sections. Quizzes will also be submitted on the e-class, and marks will be uploaded to the e-class. Equipment. So there's another video in which we have unboxed the equipment, and you can watch that. And equipment must be available to all of you, and it consists of analog discovery 2, um, then there's a DMM breadboard and some other components. So as we showed in the schedule, there will be an online help desk in which you can ask any questions that you still have. I'm trying my best to add as much detail as possible in this video, but if you still have any questions, you can definitely ask those in the online session, or if you want access outside the online session, you can send us email, and we can set a time to help you guys perform the experiments. Of course, the code of student behavior will be followed according to section 30 of university calendar. So labs are done in groups. Make sure that you have a partner, and there will be a sheet on eClass in which we will record all the partner details, and only one lab report will be submitted for each group. So the reports will not be submitted individually. You will be submitting them in groups. Make sure your partner is labeled on the um, lab report, and also make sure that in the participant list, in the group list, you guys are mentioned as partners. So there will be 4 labs in total, and each will be worth 25%. And each lab will consist of gathering data, calculating some values, generate some plots, and you can always use Excel, MATLAB, or even submit hand-drawn plots. And then there will be a post-lab online quiz that will be conducted through eClass. When submitting your lab marking sheet, use the online eClass submission link. So you can go to eClass and then submit your reports and marking sheet, and make sure that you convert them to PDF, and make sure that the size is not way too high. You can always use tools available online to reduce the size of your PDF. So we encourage you to use that. And as discussed, that the reports will be due on the following week at 4:30 p.m. for individual section. So in the lab one, we are going to use the equipment that's been delivered to you guys. There will be a software that we need to use, which is known as waveforms. So what we are going to learn in the lab, we will be learning how to read the resistor color code, and how resistances act in series and parallel. And so you might have already studied all of this in your um, lectures, and in the labs you are going to perform the practical and see get a hands-on experience on each component. So you will also observe KVL and KCL, and then at the end you will be looking at the loading effect, which is that you guys have an equipment to measure voltage or current, and you will see how that equipment affects your circuit. So this is all we observed in your lab. Let's go to the page where all the information is. So lab 1 is just an introduction to DC circuits. The objective is that you will become familiar with some of the common electrical tools and components used for circuits, and use them to experimentally test and confirm the validity of concept taught in lectures. The objectives are as follows. So you will be introduced to DC voltage. You will see how the DC voltage is given, or DC current source is given, how the resistors will work, how a potentiometer works. You will also use DC voltmeter in this lab, DC ammeter, and an ohm meter to measure resistance. and then there will be use of breadboard in this lab. So you will learn all these individual components and then use them to perform your experiments. So let's see what um, what are the required equipment for this lab. So there is a result sheet that you need to record, that you can use to record your um, values. So let's download it. So this is how your result sheet will look like. You can enter your name, student ID, CC ID, and the name of your partner, student ID and CC ID in these boxes. You can extend the box if you don't have enough space. And then in 2.1, you will be recording all the questions asked in section 2.1, which is this. And then when you go ahead, you will find 2.2 for section 2.2. So you will be recording all your values in this sheet. You will find there are some color codes used in this sheet. So anything that is white colored is done through experiments. So you will be filling up all these white colors when you are doing the experiments, and the red colors are calculation based. So these can be done without the equipment. Once you have the values, you just need to use formulas to calculate these values, and these are just calculations, not measurements. So white colored are all measurements and red colored are all calculations. And then in this part, you will plot, you will insert your plot for IV, PV characteristics, and this is all post lab work. So majorly, um, it's a small portion that you will be filling up by conducting the experiments. The rest is all calculations. Okay, so we've seen the result sheet. Now we need a computer software that needs to be installed to control our analog discovery tool. So let's do that. Okay, so this is the page where we will find the software. Yes, so latest downloads 3.14, latest installer for all operating systems. We can download this. So it's asking for some information. Um, you can fill up your information. For school, the operating system, mine is Windows 64-bit. Okay, this is how you will download the file. So once it's downloaded, we will install it. It's taking some time. But still not too much. So in a few seconds, I will have the file downloaded. Then we will install it. Okay. I don't know, I'm getting an error. Okay, the error was because I had to right click the file and run it as an administrator. So now I have the installation file um, open. So now we will go through the installation steps. Just keep pressing next and um, insert all the required values. So it will perform the installation. It will take some time. So I'm just selecting that I will reboot my computer later, but if you want you can reboot it now and then just press the finish button. Okay, so we have analog discovery 2, we have waveform installed, we have breadboard breakout for analog to discovery, and we now have all these components. Now let's get an overview of the background of this lab. This lab is just basics of DC circuits, and in DC circuits there are few simple components like voltage, which is labeled as V, current for which is labeled as I, and resistance. So using these three fundamental concepts of physics, we will be building up direct current circuits. So you can go through um, all the theory, like how a single cell voltage works and how multiple cell batteries would work and how a DC voltage source acts. So in a DC voltage source, you can select your voltage that is required, and it's direct current, so it's not going to change with the passage of time. And there's another type of voltage which is AC voltage, alternating current voltage. So in this one, your voltage will be varying with time, and we will see how that we can set using our equipment. Um, the next is electrical current. So electrical current, so if we apply any potential across a wire or resistor, because of that potential difference, the current will start to flow. And in the conventional current flow, the current flows from positive to negative terminal. And in our lab, we will be trying to find out this current flow or voltage across any resistor or component that we um, attach in parallel or across this voltage source. And there's more detail given on this page, and we encourage you to go through all of them. Usually the registers are represented using a symbol. So here are a few symbols. This is used for fixed value resistor. The next one is for is also a symbol, but it is an IEEE specified symbol. And if you have a variable resistor, then you will see an arrow that tells its variable. And if a resistor is dependent on light, like if its resistance changes with the increase or decrease of light, then you will see a symbol like this with two arrows coming in. Okay, so here we see a very fundamental form of a DC circuit in which we have a voltage source. We are using voltmeter to calculate or measure the voltage across these two terminals, and then there's an ammeter that is being used to measure the current flowing through this resistor. So you just have to keep in mind that voltage is measured across something and current is always measured through some component. So that's why you will always see that to measure your current, you will always have to break the circuit, install your ammeter in series, and then measure the resistance. Whereas for voltmeter, you can just attach your voltmeter in parallel and get the value. All right, let's get back to our main page. Then Ohm's law. You must have already studied this in your class, that um, the voltage drop across any resistor is equal to the product of current flowing through it um, into the resistor's value. You can see I equals V over R. It's just in terms of current. The current through a resistor is the ratio of voltage to the resistor. So as you will see, there are resistors in your box, in your lab kit. You can see here in this bag there are some resistors, and you will see that there are color codes. These resistors have some colors on their top. So as you can see in this one, the coloring is brown, black, orange, and then golden at the end. So you will see colors on your resistors. Now what do these colors mean? Let's see that. These colors are actually codes that tell you the value of the resistance. So there are two methods to determine the value of a resistor. Either you can use an ohm meter or read the colors that are given at the top. So first we will see how we can read these colors. Okay, so as I read that, you see there's a color on the very left. So how to decide like which is the start? You can start from either way, but usually golden or silver is the end. So I see that try to keep the golden or silver color on the right edge, and then the first band can be read out. So in my case, the resistor I'm holding has brown color. So we will use this chart and see what does brown mean. So brown color means that it's a 1. So first band is telling me that my resistor starts with 1, and my resistor is a 4-band code. So there are 4 colors on my resistor. There you will also see some resistors having 5 colors, and you will just follow the 5-band code. In my case, I have a 4-band resistor. So the first one I've identified is 1, and then the second band is black colored. So black is 0, and the third band is orange in my case. So orange is 3. So 1, 0, 3. And the fourth is a multiplier. So in my case, um, sorry, in 4-band color, the third one is actually telling you the multiplier. So my first band is brown, which is 1. Second band is black, which is 0. And third is orange. So since we are having 4-band resistor, the third is actually a multiplier. So in my case, it's 1 kilo ohm. So 10 into 1 kilo ohm is my resistor, and the tolerance of this resistor, since the last color is 5, so the tolerance is 5%. The tolerance means that this resistor is within the plus minus 5% range of the value that we've just read. Like the one I'm holding is uh, practically within 5% of 10 kilo ohms. So like I see 5 different resistors, so their value will not be exactly 10 kilo ohm, it will be plus minus 5%. Now the next is potentiometer. So potentiometer is something that you can manually adjust with hand. You will just rotate it, and there are 3 pins of a potentiometer. So the edge pins will tell you the total resistance of this potentiometer. And that is not, of course, variable. If you need something variable, you will use an outer pin and the center one. So this center one, the resistance between these two pins or these two pins is varying when I'm rotating the knob. At in one direction, one resistance will be increasing and the other resistance will be decreasing. So you will observe this in the experiments, and you can get more information from the link provided. The third is regarding breadboard. So let's pull up the breadboard. Okay, so from top, it's not easy to determine what's going on. Therefore, we have a picture, an animated picture that tells you what's inside. So you see that at the top, um, yes, so in the top row, you will see there are holes, and these are all internally connected. So you can see even in this um, picture that if we pull up this cover of breadboard, if we just take it out, we will see that there are literally some connections inside. And you will see that the top ones are internally connected, the rows of top ones, two top ones, and then the ones in the in the center are vertically connected. So we have 2 rows at the top and then 2 vertical rows in the middle, and these are separate vertical rows. So this is not all connected from top to bottom, it's just connected halfway, and then this is connected. So we can see like A, B, C, D, E are connected internally, and then F, G, H, I are connected internally. And same goes for the bottom row, minus and plus. So they are all horizontally connected. You can also see there is another picture that provides details, and there are small um, connecting pads inside that will hold your component when you insert it from the hole. All right, now let's go to the waveform software that we installed. It's already running on my PC. Now connect the analog discovery tool. Use the provided USB A to micro B cable to connect your analog discovery tool to the USB port on your computer. We have done that. The next is connect the one end of the ribbon cable with the notch in the proper orientation to the analog discovery tool as supplied. So um, let's do this. Now here is my analog discovery board. Here is the header. Just take it out. And I will simply insert it into the breadboard. Now I will make sure that the last one enters inside, and I will try to position it in the center, even horizontally. So second from the bottom, and same goes for the bottom row. So make sure that you are installing not installing in the edge but in the center, so that you have access like this. Just press inside. Next is that you will connect this jumper cable so you need to make sure that you connect it to in the correct direction. Let's see the instructions. So we need to make sure that the orange wire of the ribbon ends up on the same side as the board labeled as +1. So you see that there is a +1 um, labeled. So here you see there is a +1 labeled on the board. So just make sure that you connect the orange one exactly on the same side. So this is how you're going to install. And then the other side, just make sure that the notch enters here in the gap. Just plug it in. Okay. So congrats, you have made the first connection. Now this breadboard is these points are connected to the Discovery 2 device. Now let's get to the next part. Okay, now I've opened the waveform software, and here you can see at the bottom that my Discovery 2 device has been connected and the software has detected it. You can see there's a status OK comment at the bottom, and there is also a serial number indicated there, which confirms that your device has been detected. And now we are confirmed that the device is connected, we can use this equipment. Now this equipment has got several features. You can see on the left side there is scope, wave generator, supplies, voltmeter, logger. So this equipment can perform several operations. To understand it more, let's use some of them. So first, let's start with the supply option. Using this, we can generate several different voltages. You see there are two voltages. We can generate V positive and we can also generate V negative. So there are two separate pins given on the board. You can see that how we have connected it and on the board. So using this, we can simply generate different voltages. At this moment, the master enable is turned off. You can see at the top. So there is no voltage being supplied at this moment because it's just turned off. But if we want to turn it on, we can simply click it there. Before that, we will just have a brief look over different properties. So currently the voltage is set to 1 volt for the positive terminal, and for the negative one it's set to -1. We can simply change the positive voltage by using this slider, or we can use the drop down menu and select a voltage, or we can even manually add voltage if you want. We can do the same for the negative voltage as well. We can simply press the drop down button and select the voltage we want, and it will appear on the V plus and V minus on your boards. So you can look at your board where the V plus and V minus is, and using those terminals you can simply get the uh, the voltages that you're setting in the software. So if you look at the board, there is V plus and there is V minus on the green board. So you will have to attach your component on those specific points. And as we've discussed previously how to use the breadboard, just keep that in mind and make sure that you connect one of your wires on that side. We can turn off we can individually turn off supply, and you see that when I clicked on the negative supply, it's just turned off, although currently even the master enable is turned off and we will not get any voltage at the output. We can also turn on the tracking option, and when it's turned on, both the positive and negative voltage will follow the same value. So if we invert any value like 3.5 in the positive terminal, it will be same on the negative terminal. So tracking will actually ensure that both the terminal has same voltages. It's just used for ease. Like if we want same positive and negative voltages, we can just turn on the tracking option. Now I'm simply going to stop my board and see if we can measure the voltages that's being generated. So for that we will simply follow the instructions given, and we will connect the V positive of the board to the 1 plus uh, on the board. So we will be connecting the positive supply to channel 1 of this discovery 2, and in the same way we will connect the negative supply to channel number 2. So we will connect V plus to 1 plus, and then to 1 minus we will connect the ground pin. Remember that ground is the common pin and there are 4 pins on this board. So we will simply connect the wires, make sure that we connect we use the breadboard as we discussed before. We will connect um, to, to the same column of V plus, and then we will connect it to the 1 plus of the board. And in the same way we will connect the ground of the board to the 1 minus. So this will ensure that we are measuring voltage across the positive terminal using channel number 1. And in the same way we will connect channel number 2 as well. So we will connect V minus to 2 plus, and then ground to 2 minus of the board. Alright, once we have connected, we will go to the welcome dashboard and select voltmeter option this time. And you see that we have single and multiple run option. We will click on the single, and we see since now we have only connected to channel number 1, we see 1 volts. So we've set 1 volts in the supplies tab. So we see around 991 millivolts. And for channel 2 we don't get anything because as of now we have not connected anything to channel number 2. But for channel 1 you see that we've set 1 volts and we are getting almost around 1 volts by using the voltmeter. We are confirming this. See that we have selected 1 volts. Now we can change the voltage to 2 volts and go again and run and give it a single run. You can see that it updates and tells the uh, new voltage, which is around 2 volts. Okay, now we will continue ahead and connect the negative supply to channel number 2. So you will just make sure that you connect the pins properly. Connect V minus to 2 plus, and then ground to 2 minus. Yes, so this is how you will connect all the terminals. And then if you go back to the voltmeter option and click on the single, you will see that the voltage is now appearing on channel number 2. So we've set the negative voltage to -1 and positive voltage to +2, and we see that in our voltmeter readings as well. Next, in the lab manual, before we do that, let's just stop the voltage supplies. So let's go back to our Now let's see what's next in the lab manual. So in the next one we have we are going to see how a digital multimeter works. So a digital multimeter is simply a test tool, and I believe you can just read out the details provided, and there is also some instructions given in case you would like to change, or you need to change or insert the battery of the voltmeter. Let's just so let's get this voltmeter out of the box. So the first one tells you to turn the knob of your voltmeter to ohm. So you can see there's a symbol, ohm symbol, omega, on the voltmeter. Just turn your knob from off to that ohm, and inside these functions there are sub functions. So when you press the function button, you will change from ohm to diode, and then if you press it once again, you will turn to beep function. Beep is actually a continuity test function, and if you simply connect the two ends of your wire, you will see the continuity test tells us that the circuit or the voltmeter is short circuited. So let's turn it back to ohm. Currently it says it's overloaded because we don't have anything connected, so there's a very high resistance between these two terminals. Now let's connect these two terminals and see what we get. So once we connect them, we see that the resistance is around 0 ohms. Okay, now in the next one you will be measuring resistances in series. Now either you can remove um, your discovery 2, or what you can also do is that you use rest of your breadboard to perform the experiment. So we have empty section here, and we can simply use it. Now let's pick up a resistor. We have several resistors available. Let's pick up one. So I'll pull out one from each, and we are going to measure the resistances of resistors when they're connected in series. So now we would like to measure resistance of these resistors, and before that we need to connect them in series. So let's do that. First, simply insert them in the center area somewhere. So there are multiple ways to connect them. We can connect it like this. So we just need to make sure that we are not internally shorting these resistors. Like if I connect this resistor like this, then it's a problem because this breadboard is internally shorted. So the current will prefer to flow from inside instead of the resistor. So we will not be getting any resistance in this case. Either we can connect it this way, because as these two compartments are not connected internally, so this is fine, or you can just insert it like this. This is also fine. And now we need to connect the second resistor with the first one. So as we know that the breadboard is internally connected, and for this portion it's vertically connected. So I can simply insert my resistor um, in one of the holes that is vertical. So you can simply see that how I've connected it. Now I will be measuring the resistances. So to measure the resistance, it's good that we install alligator plugs to our DMM. You just simply have to slide them in. And let's first connect it across our first resistor. So this one at one terminal, and then one on the second. So at this moment I have connected it to only one resistor. I'm getting a value of around 1.478. Should be 1.5. So if I read the color codes, and if we just go at the top and read the color codes, so now at the moment I have a resistor which is brown, green, red, golden. So brown is 1, green is 5, and red is 100. So it's 1500, which is around 1.5. And the gold color tells that the tolerance is around 5%. So it is within the tolerance, and now we can connect it. So we have two of them in series. Now let's connect it to the first pin of the other resistor. So now you can see the circuit is somehow like this, that the positive is connected to the terminal of first resistor, and then the current flows through the resistor and then reaches the other lead. The other lead is connected to the second resistor, to the first lead of the second resistor, and then the current flows through the second resistor, and then eventually from the last lead it enters back into the DMM. That's why at this point we are facing resistances of both the resistors. So at this point now I'm getting 3.64. So for this second resistor it was 1.5, and um, now I'm getting a combination of 3.6. Let's check the first resistor only, and this is around 2.1 or 2.2. So the combination is 2.2 plus 1.5. So I'm getting around 3.67 or around 3.7 with some error, of course, because of the tolerances of the resistors. All right, let's go down. Now, what happens when we connect the resistors in parallel? We've just seen that if we connect them in series, the current faces overall resistance, which is the sum of both the resistors. Now, to connect them in parallel, make sure that you connect them so that they're both leads. The first lead is vertically connected to the first lead of the other resistor, and the second lead is also connected. So we need to make sure that we are connecting the leads in the same vertical column for both. Alright, now I can connect this DMM, and since this is internally connected for black one I can connect it to any one of the resistor, and same goes for the red one. Now when you're connecting this alligator clip, just keep it in mind that if you connect it so much close to the breadboard, it will try to pull your resistor out of the board, and maybe you don't, that can become a reason that you don't get proper values. So try to install it at the top so that the weight will push it inside the board. Okay, make sure your looks like the resistor or this is not properly connected. So when I'm connecting them in parallel, 2.1 in parallel with 1.5, I'm getting a small value. The reason is that because the current now has two ways to flow, so it distributes itself and overall resistance is dropped. Okay, now let's use our DMM. In the next section, we will be using our digital DC voltmeter to measure the voltages. So in the next part, we will be using DMM to measure the voltages. Let's take it out of the board. Now let's change this to voltmeter. So there is a V written here. You just bring the knob to V, and you will see that currently it's showing AC voltage. Since at the moment we have DC, we will press the function button. Now it's changed to DC. So remember, every location of knob has multiple functions, so we need to press the function button to get the one that we're looking for. And now what we are going to do is that we have V plus. So now we will pull out the 1 plus because we want to connect our voltmeter to the V plus of Discovery 2. So let's connect this, and we need to connect um, another one to the ground. So let's take this out and connect it to ground. Now I get a 0 volts because I've already turned off the voltage. So we will go back to the software and turn on the master enable. So master is enabled. Now we see a voltage on our digital multimeter, and make sure that it's on DC function and not AC. So you will see the same reading on your digital voltmeter, and as you change the voltage, as you change the supply voltage, you will see different values on your digital multimeter. So currently I've set it to 4 volts and I see almost around 3.99 volts on my digital multimeter. And it's simply that I've connected my voltmeter to the V plus and the red of my voltmeter to V plus and black to the ground pin on the green board, which is connected to Discovery 2. So this is how you're going to perform this experiment. So you can also use this voltmeter to measure DC current. And in this part, it's only explaining how to use your voltmeter. But at the moment, don't change any pins. First, remove it, and then only you should do it. So remove any connections that you might have. So we have removed the wires. Now it's just explaining that how you will be measuring current using this device. So whenever we are measuring current, this device will be connected in series. So most DMMs have multiple inputs for current so that different ranges of current can be measured accurately. This one has two separate inputs. So you can use this one for milliamp or microamp measurements, and this one if you have high current. So this this port can measure up to 630 milliamps, whereas this one can go up to 10 amps. But the accuracy in this one is less, and in this one the accuracy is more. Now in the next part you will be applying Ohm's law and power law. So now you have to connect a circuit, make a circuit same as the one shown in this um, schematic. Now use the positive DC supply from analog to discovery. So Vs will be your V plus from the discovery to device, and then this will be the ground. Use the voltmeter from the analog discovery 2 to measure VR. So this part will be measured using VR, the voltmeter of discovery 2, and to measure use the DMM as milliammeter to measure IR. So you will use DMM to measure the current. You might want to use header pins to connect the DMM's probes to the breadboard. Now keep in mind that the current is always measured in series. So we just have to make sure that our ammeter is connected in series with the resistor. So at first use a 470 ohm resistor for R1, then change this resistor when required to either the 1 kilo ohm or the 4.7 kilo ohm. So at this point I am simply going to use the resistor I have, but you should follow the instructions given in the lab manual. So I will simply place this resistor here, and connect the positive terminal to one end, make sure the voltage is turned off. Let's first turn off uh, the voltage before we do anything. So we should be connecting the voltage supply to a separate column because we don't want to directly connect it to the resistor. The reason is that we have to connect the ammeter in series, right? So we can use two more cables to do that. So we will connect this one here, and then to the red one, and then the another cable will simply be connected to the resistor. Okay, now the resistor, the other lead of the resistor will be connected to ground. So I have a ground here. I will simply connect it to the ground. Now I need to change the ammeter, the voltmeter to ammeter. Now here I can get microamps, milliamps, or even amps. So first let's keep it to milliamps and change it to DC function. Okay, now I'm connected to, now I have activated the DC function. Um, Now let's go to the circuit. Looks somewhat like this. I have voltage coming from the analog discovery. It's connected to a separate column. That column is connected to the red one of my voltmeter, or sorry, ammeter. And then the black one is connected to the resistor, and resistor is connected in center. So the other lead of resistor is connected to the ground. Something like this. Alright, now we will go to our waveform software and set voltage to 5 volts and turn on the master enable pin. Make sure your DMM is having all the proper settings. And you're measuring DC voltage, so make sure the function is set to DC. Now we will connect all the pins as mentioned in the lab manual. So we have connected our ammeter in series. Now to measure voltage, we can use the voltmeter of our Discovery 2. So we will connect one end to V plus and the other end to V minus of the Discovery board. So once we are set, we will turn on the voltage. We will make sure everything is set Now we will go to the voltmeter and give it a single run. You see that all the voltage is being dropped across the resistor and the current is being shown on our DMM. The reason all the voltage or the reason we are getting 5 volts is because we only have one resistor and the whole voltage will definitely drop across it. See what we have next. Before we go ahead, one thing I would like to show is that the voltmeter is connected in series, right? So if I somehow accidentally remove the voltmeter, you will see that the circuit will no longer be giving the value. Like you see in this one, I have my ammeter connected in series, but if I remove it, you see that there is no more current flowing through the circuit, and I'm getting zero. And if you run the voltmeter, you will get 0 volts across the resistor because the circuit is broken and there is no current flowing. Right, now let's get to the next part. So in the next one, you will be implementing a voltage divider in which you will have multiple resistors connected. And you will observe that the voltage dropped across each resistor is the sum of voltage supplied by the power supply. So to perform the experiment, you will simply connect two resistors. You have multiple channels on your discovery tool, so you will connect one channel across one resistor, then second channel across the second resistor. You will also use your ammeter, and then you will use discovery to supply the voltage. Use the positive DC voltage supply from analog discovery tool as Vs. So this Vs will be supplied from the discovery tool. Use voltmeter meter channel 1 and 2 from discovery 2. Use DMM as milliammeter to measure IS. Use a 470 ohm resistor for R1. At first, use a 100 ohm resistor for R2 and change this resistor when required to either 470, 1K or 4.7K based on the values in your result sheet. So let me set up the circuit for you so that you could follow, and I will be using random resistors instead of the actual one. So you just have to connect two resistors in series. So we have this one placed here and the second one in series. So we need to make sure that one lead is connected in the same column of the breadboard. Now to supply the voltage, I have this green one connected to V plus. So I will connect it to one of the resistor by inserting it in the same vertical line of the first pin of this resistor. So this will be the supply, and for the ground I will simply connect this black one to the other end of the resistor. Now since I also have to measure the current flowing through this circuit, so I will have to break this one and connect it to the DMM, to the red side of the DMM, and then connect another lead, the other lead of the DMM, to the resistor. So now we have our ammeter connected in series, and this is how your circuit will look like. We have two resistors that are connected in series. Just make sure that the pins are connected correctly, and your main V is coming through your ammeter, which is then connected to the resistor, and then finally the edge of other resistor is connected to the ground. And now we are going to connect the channel 1 of voltmeter in the discovery tool across the first resistor. So we will connect it to the point where we've connected the pin from wire from the DMM, and then the 1 minus will be connected to the point where we have connected the two resistors. So just make sure that you make all the connections properly. So 1 plus will be connected to the top of the first resistor, and 1 minus will be connected to the second pin where the two resistors are being connected. So this is how the circuit will look like. Now we will connect the other channel. So 2 plus to the point where both the resistors are meeting to that junction, and then 2 minus will be connected to the second end, to the other end of the second resistor. So just make sure that all the pins are being connected properly. So we need another jumper wire. We will get it from the bag. We'll just connect the 2 minus to the other pin of the resistor. So now the whole circuit is complete, and just make sure that your ammeter is set to DC. We will go and turn on the voltage. Just enable the master. So now the voltage is being supplied, and if you go and measure the voltmeter, just give it a run, or it's better that we just give it a single run to get a stable value. You see that we are getting 3 volts across one resistor and 2 volts across the other one. But in your case, since I'm using arbitrary values, in your case you will use the values as given in the um, manual, and um, based on those values you will get different results. But just use the values given in the uh, manual and record the results that you get from ammeter and the voltmeter. Now we are going to verify Kirchhoff's current law. And to do that, so Kirchhoff's current law simply states that current flowing into a node is equal to the current flowing out of a node. So for that, we need to set a current source to perform this experiment. So in the first part, we will be setting up a current source. And for that, we have a small component in CK209 parts bag number 1. We will take it out. And by following the instructions, it says that we need a 20 kilo ohm resistor at the set pin and 20 ohm resistor at the out pin. So let's go up and see the color codes. So 20 kilo ohm would be red, black, orange. So let's see which one is. Here I find red, black and orange. This should be 20 kilo ohm and 20 ohm should be red, black, black. So here it is. Let's connect 20 kilo ohms. Let's first disassemble the previous circuit. Try to be gentle because these wires can be broken easily, and then you might not even notice. You will be doing experiments and you don't get the correct results. Okay, let's go to the current divider section and let's attach our IC first. Before attaching it, just keep in mind that the first pin is on the extreme left. So when you are reading it, make sure that the header is at the bottom and the pin on the left is the first pin. So we will simply insert it in the breadboard like this. Now in the next part, we will insert the resistors. So let's connect the red, black, orange to the first pin. We can connect this resistor to any of these vertical lines, then the second can go somewhere ahead. Let's keep it a bit close because we need to attach another resistor as well. And let's connect the 20 ohm to the center. From the center to the same point that we connected the first resistor, like this. So you see that they're shorted, they're on the same junction at this point, but here they're separate and they're connected to separate pins. Okay. Now in the next one, in the next step, pin 3 of the device needs to get connected to the V plus of the analog discovery tool. So we are going to connect V plus, which is here, to the third pin of our IC current source. This is how it will look like. So we will connect the V plus to the N. Now by following the manual, we will connect all the remaining ports. So we will, since we need ammeter in series, we will connect a red one to the point where both the resistors are shorted, and by following the manual we will see the next steps, in which we will connect the black one to the ground. Now we will see what's written in the lab manual. Now we have connected the current source. We will go to the software and turn on our supply. We need to make sure that the V plus is at 5 volts and V minus is at minus 5 volts. So we have connected our IC to V plus using the green wire, and to V minus through our DMM's black cable. So this is connected to the V minus, and red is connected to the resistor, and eventually our IC is connected to V plus, and on the volt ammeter we see 10 milliamps current flowing through this circuit. So this is now a current controlled circuit, and we will get 10 milliamps, and using this we can perform the experiments and verify the Kirchhoff's current law. You just have to connect this circuit, and since I've already shown you a couple of examples, you should be able to stuff your breadboard with these resistors. Make sure you pick up correct values and then insert it as shown on this diagram, and also connect the voltmeter as mentioned, and simply perform this experiment. And now in the next section we are going to use potentiometer divider. So let's turn off the voltage and let's bring in the potentiometer. So we need to use this potentiometer in our next experiment. So this is very simple one. We will be connecting a 5-volt voltage supply, an ammeter with this potentiometer. So we will simply connect this potentiometer on the breadboard. We will connect our V plus at one end of this voltmeter. We just need to make sure that we are connecting on the correct column of the breadboard. So I've connected the positive side, or I think it's better that we connect the positive side to the ammeter just to follow the schematic. So it's connected here. The black side will be connected to the potentiometer, same as what's shown in the schematic. And then the other end is connected to the ground. We will simply connect it to the other end of the potentiometer. Now we also need to connect voltmeters, so we can use 1 plus in this case of the discovery board and connect it across the potentiometer here, and then of course the 1 minus should be connected at the center, because we need to measure voltage across the first part of the potentiometer. Now 2 plus will be connected at the center, and 2 minus will be connected at the other end of the potentiometer. Okay, now this is set up. You simply need to go to the software. Now through the software we will turn on the voltage supply by clicking on the master enable. Now you can observe on the ammeter the amount of current flowing through the potentiometer. Make sure it's on the DC function, and using the voltmeter we will observe the voltage across the terminals of potentiometer. So the wiper of potentiometer is currently at its extreme position. That's why we get 5 volts, all the 5 volts across one terminal, and the other is almost 0. So let's run it on continuous mode and start to rotate our potentiometer. So you can observe how the voltage across the wiper terminal is changing now because it's moving from one end to the other. So you see that one part is now almost short and the other part is showing maximum resistance, and that's why the whole voltage is being dropped across the lower part, which is connected to our channel 2 of the voltmeter. But you see that the current through the circuit is not changing. You will observe on the ammeter that the current remains same because the overall resistance of potentiometer remains the same. It's just that the wiper terminal, which is the center one, is changing. Let's see the last part, which is loading effect. The loading effect is to what degree a measurement device impacts the electrical properties of the circuit under test. So now we will observe that when we connect our equipment, how much does it impact our circuit. So for this experiment, we need to set up a circuit like this. We will get 5 volts from our discovery board. We will connect 10 mega ohms resistors in series, and we will connect a non-ideal voltmeter across this R2. So non-ideal voltmeter is anything that we are connecting. We will use our DMM in parallel. So let's just turn off the previous voltage that we applied. We simply need to connect two 10 mega ohms resistor in series. I'm just going to show how it will look. Let me just unplug everything to make the board look clear. So you will simply connect two resistors of 10 mega ohms in series like this, and then connect your DMM as voltmeter, which will be like this. Make sure that you change it to DC, and then you will connect it across your resistor, or if you are giving your P positive to this resistor, then make sure that you connect the red one on the top and the black one at the bottom, where you are going to connect the ground. Right, and then you will turn on the voltage, follow the steps, and you will see how this voltmeter is affecting your readings. Now when you are doing the measurements for ammeter loading, you will be making a very simple circuit in which you will connect this voltmeter in series with the 10 ohm resistor. I'm simply going to use a random one to just show you guys. So this is how you will be doing it. You will change the knob to milliamps and make sure you change the function to DC, and then the supply will be connected to your multimeter. The other end will be connected to one side of the resistor like this. Let me change the view. So we are simply going to attach two resistors in series, and we need to pick up big values for measuring the loading effect for voltmeter. Just follow these steps for the ammeter and the things that we discussed before. Just keep them in mind. And if you have any questions, you can send us an email. Just make sure you contact your respective TA or LI, and we will be happy to help you. Thank you.